So today's session is part of a month-long series hosted by Gwyn, a cloud advocate here at Microsoft. She'll be taking us on a journey through Azure, focusing on topics that are part of our Microsoft's 30-day to learn it challenge. I will share the link to the challenge in the chat, so if you're interested in participating in that, feel free to sign up. Her guest today is Rishab, DevOps Engineer, and today their session will be covering from polling to push-based with Azure Functions, SignalR service, and Cosmos DB. The session will run for approximately 60 minutes with time for questions throughout. If you have not done so already, please check into this session to receive the session resources so that you can participate on today's event. So let's bring our host and guest up today. Hi, welcome.
Thank you for that introduction. Hi, everyone. Hey, Rishab. How are you doing?
Hey, Gwyn. Good.
I wanted to, before we dive into the demo, we have like a lot to get done today, so I want to dive right into it. But I do want to mention, so Rebecca spoke about that 30 days to learn it challenge. I know, Rishab, I think you've done some of these, right? They're pretty cool, where you sort of commit yourself to doing like a learning path in a bunch of modules, depending on which one you want to do. For this specific series, I'd recommend going for the developer one because I've selected modules that sort of follow that learning path. And at the end of that, once you complete the challenge, you could be eligible for a discount voucher for certification, which is fantastic. We're big fans of certifications here. I think we've spoke about this previously, but yeah, I think it's a great way to sort of have some like maybe group accountability and sort of a little game aspect to learning new things and getting more familiar with Azure and developer technologies and things like that. Yeah, cool. So everyone, of course, feel free to ask questions in the chat. And Rishab's going to be helping out, sort of taking a look at that, and we can dive right in. Let me add my screen to the stream. There we go. Okay, cool. So this is the GitHub repo that we will be utilizing for today's demo. And when you check in, you'll get the link to all of these things. So I highly recommend doing that. What we have going on right now is I'm going to open up the architecture here that we made the other day with Rishab, and the CoinGecko. If anyone's familiar with CoinGecko, their logo is adorable, like their mascot or whatever. But anyway, so right now we have this sort of static website built with Blazor. I'm a big fan of Blazor, as many of you know. Right now it's fetching data from an API, which is the CoinGecko API. We based this demo around a Learn module that is also provided to you when you check in. But we wanted to create our own spin. So crypto is sort of all the rage these days. So we're like, let's make something crypto related, right? So our sort of project is we have a static website. It's deployed on a Azure Blob Storage, and it just fetches data about cryptocurrency prices and changes in market and such things like that. The sort of downsides to this is the only time you get sort of new data is when you refresh the entire page. So you'll have to visit the page again, and then it'll make a new call to the API, and we'll take a look at how this works in a second. What we want to end up doing is, which is the completed project, is we'll have that same static site, but we're going to be utilizing something called SignalR service. If you're familiar with SignalR, it's a library that allows you to implement real-time functionality with your web apps. And SignalR service is the sort of SignalR as a service hosted on Azure kind of thing. So a lot of the infrastructure provisioning, scaling, and all those things are taken care of by Azure. So we're going to utilize that. We're going to use Azure Functions, Cosmos DB, and sort of create this infrastructure that comes in the middle. So we'll have an Azure function that will negotiate the connection to the SignalR service. And the SignalR service is going to be receiving the new messages from the API calls. So that way we don't actually have to reload the website anymore for new data to come in. That data is going to come in real time, right? So yeah, this architecture you can find in the Git repo. We'll take a look a little bit. Let me zoom in more so it's a little easier to take a look at here. So the starter, that's where we're going to start. And you see we have in here crypto ticker and the API. And then once we're done, we'll have this sort of similar structure, but you can see that we'll have like the things filled out. To keep things brief and sort of to get like the nitty gritty, I guess more of like the annoying details, I've already gone ahead and created a resource group for us. So it's called Pull to Push Resource Group in Azure. And then in here, I've created our Cosmos DB account, our SignalR service, and then our storage account. I've done this because provisioning that takes like 10 minutes or so, and then that takes away from time. And there's a bunch of other details in the repo, sort of explaining the architecture, the steps you have to take to sort of reproduce this demo, and how to run it locally, and a little bit more about SignalR and persistent connections and hosting the site as well. So do take a look at that. We can go ahead and open up that project. I have it here locally. I think I'm in the right. Let me go back one. Yes, crypto ticker. Okay, so we're going to, let's go ahead and open up the whole project. Here, it's open already. All right, let me know if this size is good, like everyone can see. I want to make sure everyone's not like squinting their eyes to be able to see what's on the screen, because I know when it comes to fonts and like text and things like that.
I think it looks pretty good.
Looks good. Yeah, I might struggle a little bit because there's a lot less real estate for me to use and like move around, things like that. But yeah, okay. So I'm gonna close everything and we'll start from like sort of the beginning. So like that repo has, you have the completed project and the starter. We're gonna start in the starter, right? And then in the API, this is where our functions are going to live. And then in the crypto ticker, that's where our Blazor WebAssembly project, so our front end, so our static website lives in here. So I'm gonna bring up the terminal, and then I'm gonna make sure, let's go to starter, and then I'm gonna clear this. Whoops. Move into the, okay, so we are now in here, and we're gonna just run this .NET watch run. And we're gonna run this, and we're just gonna take a look at how the project is when you call in from GitHub and what it actually does, right? I see a bunch of hellos in the chat, so.
Yeah. So right now it doesn't utilize any of the functions, right?
No.
Okay.
So I'll explain a little bit more of like what I've put in place. So sort of like a boilerplate there for us. But yeah, so you launch it, .NET run, and we have this running locally. And if we go on here to the left side here, we click on tickers, and you see we have our prices. And then this is all pulling from an API, right? So we're using what's the component library? Oh, Blazor. So when you create a new Blazor WebAssembly project or Blazor server-side project, you get this sort of very standard-looking template that has like a purplish bar on the left side thing. Mm-hmm. So we sort of wanted to be honest, we sort of got a little carried away with playing around with Blazor, so that's why it looks like this way. This isn't absolutely necessary, but we just wanted to make it look pretty. So that's why we have like sort of like, this toggle light dark theme, and then a link to the repo and all these kind of things. That little animation, Rishab like figured that out too. So yeah, what we have here is some cryptocurrency data. So you have like the ticker, the image, the current price, if it's gone up in the last 24 hours, if it's gone down in the last 24 hours and such. So and then I think there's like 100 here.
Yeah.
Something like that. Yeah. Okay. So that's our sort of our static front end, right? And in terms of the pages, if we go to fetch, I think it's fetch data.razor, we have a component called, this is the struggle bus here because there's not a lot of space. Yeah, so in our fetch data, which is our page that we have loaded here, fetch data, we see match here. We have a component called ticker, and then our tickers here, and that's just what's loading our data. And like I mentioned, we have a lot of these Blazor components in here, just utilized to make it look prettier, right? And the actual data, .cs, so the file that has the logic of the component is in here, and the magic is in here. This uninitialized async, it just goes and makes a call to the CoinGecko API, right? So that matches the architecture that we mentioned at the beginning. Now, if we go to our API folder, I have already created some functions for us, again, just to sort of save time on the creating all these things. And in here we have a timer function. So I just created them. I didn't do anything with them yet. So I'm actually going to stop running the Blazor page, and then I'll show you what's going on here. Mud container. So the package is Blazor. Do we have the link? I think it's mudblazor.com.
Yeah, it's mudblazor.com.
Yeah. Okay. Cool. So let's close this up here. So if you've used Azure Functions before, there's a bunch of different trigger options. We're using the timer one, and we're set it to run every minute. So our goal right now is to implement a timer Azure function that will execute every minute and just call the CoinGecko API. And then each time it calls the API, not only grab the JSON, but save it to Cosmos DB, to a Cosmos DB account, database collection. And then also that same JSON data, that payload, we're going to go send it off to SignalR service. So that any client that's connected to the SignalR hub will receive the new messages and then update in real time. Okay, so this is pretty standard. Again, I just created it and left it there. All right, so now what I'm going to do is we can also show the other files that I have. So I have this .cs file. So this is describing the JSON that we get from CoinGecko. So we have an ID, we have a symbol, we have a name, image, and such. And then I have everything else is pretty standard. Yeah, and then we have one more function to create after this, but we'll start with this one too. So there's a couple of packages that you'll need. You'll need the SignalR package for Azure Functions. We're using .NET 5 here. And then you also need the Cosmos DB one. You can get those from NuGet. But they're already in the project when you clone it, so you won't have to import them again. Should we have any questions so far?
Not so far.
Cool.
Yep.
So first thing we're going to do is sort of dive into creating the Cosmos database and such. I think I already have that though provisioned. Let's go in here. So if we go to here. Yeah, so I've created a Cosmos DB account called poll to push Cosmos. And then our database is called crypto coins. And then our collection is called price. And then in items, I don't have anything in here. You do need to make sure that you grab the connection. So if you go to keys and then you go primary connection string, you're going to need to add this to your local.settings.json because that's what enables you to talk from your function to your Cosmos DB account. Right, so nothing in here yet. And then we also have our SignalR. And then here as well, you'll have to grab the key from the keys. You'll grab your connection string, which would be this one here. And then you'll copy that to your local.settings.json right here. And I've already filled that out for us. So this is a file that I'm actually not pushing to the repo, but if you create one and then add these exactly like this, Cosmos DB connection string, the database name is crypto coins, we just saw, collection name is price, and then Azure SignalR connection string, just paste them in there. Another thing that I've added here is our local HTTP port 7071. That's where our function is running locally. And that's so we can have CORS enabled. I just sort of set this to all. But in production, you would want to be more specific to where you want to enable CORS for. But locally, this is completely fine. Now we're going to jump into actually writing out the function that will pull the data from CoinGecko. I just need to pull up the URL for the CoinGecko call that we're making. Let me find it here. One sec. Okay, cool. So let me close this out here, and then I'll just add it in as a comment. So I guess we could bring that up too on here. So we see we have a bunch of just JSON data, right? Yep. That's probably not very easy to look at. We'll close this. We have this here. We'll need this open. We'll need this open. I'm just trying to see. We'll probably close this one too. Okay, cool. So first thing we need to do is, can I go one? I wanted to go one smaller, like that. Is that still good enough to see?
Yeah.
Do you think so?
I think so.
I just need a little bit more space here. All right. So first thing I'm going to create is sort of in somewhere just to save our data in. So we can start by creating an array of type coin, which is that class that I showed everyone, which we're going to save the JSON data in. And we're going to call this coins, I guess would be, or prices maybe, prices. Coin prices, and this is of type this one right here, right?
Okay.
Then we're going to go ahead and use using HTTP client, HTTP client, we'll probably have to import a package for this one since I created these from scratch. They don't have it. And oh, you know what? We're probably running into that error that I had yesterday. Select project. Which one would it be? Crypto ticker. We're in the back end, so it's API.
Yeah.
We're in the starter one here. Yeah. So this is an issue I ran into yesterday, which Rishab figured out, is when the IntelliSense is not set to the correct CS proj, then you won't get like these errors, and then you're kind of just like guessing things. So if we click on this one, it says yes, we have to use system.net.http. Cool. All right, great. So now we're going to need to use this URL to actually make the call out. So we can say var coin data is going to equal await the HTTP client that we called here, client, and then we're going to say get async, and then here we should be able to provide the URL, which is this one here. Copy that, and then paste that in here. Fantastic. So now we have in here, we'll go ahead and create the call, and then it'll save into this variable coin data. Mm-hmm. What error am I getting here? Oh, we have to change so it's telling us the await operator can only be used within an async method. So we'll probably have to do public async. I think that's enough. I think so. We'll see. We'll see when we run it, what errors we run into. And then we need to get the body. So we'll do var body. Body is going to equal await coin data dot content. Yes, I believe so. And then we need to read this as string async. All right, and now we need to sort of parse the data into a model that we're familiar with. So we can add that into the prices, which is this over here. Remember, prices is of type coin. So prices equals JSON serial, and it's probably not completing because I don't have it. What's the package for this?
Thing system.
Text
JSON.
System.text.json. Yes, I think you are correct. And we'll do JSON serializer. Yes. And then we'll do deserialize coin, type coin, and we need to provide the body. Here we go. Okay, so we're making the call to the CoinGecko API, and then we're grabbing the content. We're going to read it as a string, and then we're going to sort of mold that content, that JSON data, into something that we're familiar with. We can work with the objects, which would be coin. And then we could probably do something like for each, and we'll just print out like the symbols just to make sure we're grabbing the data correctly. So for each like var, yeah, I guess coin. For price and prices, we'll do price and prices. We'll just log to console logger dot to, what's it called? No, we have it over here. Log information, and we'll just put the price dot symbol. Yeah, I guess that would be easier. Maybe name. No, do we have name? Yeah, we have a name too. We'll just print the console of each coin, right? So now we should be able to run this. Let's see what errors we get. That's the fun part. Run here. Well, that's because, all right, we're going to have to do it this way. CD to starter, and then we'll move into the API, and then we'll do func host starts. Yeah, so the reason that didn't work is because we have like multiple, we have the starter, we have the completed, and then we have inside each one, we have multiple like different projects that we could execute. So it doesn't know which one to do, so I'll just do it manually. You know what I forgot to add? So when you're working with the timer trigger, you have to include this run on startup.
Oh yeah.
That way, each time you execute it, you don't have to wait for the amount of time that you specified in here. Mm-hmm. And then we'll just set this to true. All right, cool. That should work. So what comes in now is you'll have like an output of each coin that.
So we would see names, right?
Yeah, it should grab names unless I didn't. Let's see, var coin data, var price and price that name. Unless it's going to make us right. Let's see. It's going to make us wait to full 60. I don't think so. Prices. Price that name. No, it's executing. Hold on. Let's see. Let's see. JSON type coin, read a string, glug coin dot for each var price and prices. Yeah, I don't see why this doesn't. Let me take a look here. What am I missing? Read a string async body var prices equals JSON serialize coin body for each. It's probably. Do we have to do this inside the HTTP call?
Not sure.
Probably not, because we're saving. No. We're saving.
Do we have a var already named as price?
Yeah, it's right here.
Oh, okay. But then the class itself is coin, right?
Mm-hmm. All right, let's do this. Go into here and let's grab every. Will it hit breakpoints if I'm running from terminal, not like debug? It should, right?
I think so. I think there is a flag you can.
Like if I run func host start instead of actually.
I think you can do. I don't know what the.
Yeah, all right, hold on. We're executing, running on startup. We saved everything. JSON serializer coin body for each.
Shouldn't it be. No. Wait.
Is it task? Is it because we're doing?
Could be.
Oh, that's probably it. And then we have to do that. I think that's it. We're doing, there we go. See, I was returning the wrong type. My mistake. All right, cool. So yeah, we go live debugging. Awesome. Yeah, so we have now all the names of the coins that we're sort of getting from the API. And then, you know, Bitcoin, sushi, there's a sushi coin.
Yeah.
Zcash, Harmony, yeah, but there's just a bunch in here, right? So now what we want to do is add the next step, which is add, when we grab this data, save it not only to, well, you know, we're not only just going to print to console, we're also going to save it to Cosmos DB account.
Mm-hmm.
And then also sort of publish it to a SignalR hub. We're going to stop this here. And with functions, when you have multiple outputs, when you're using .NET 5, you actually have to create a custom output, because if you're using just one, you could do like, you would add a, like an attribute up here, like Cosmo, square brackets, Cosmos DB output, and then you would specify like your database, the collection, all that kind of thing. But you can't add like more than one. Like you couldn't add like a SignalR beneath this one. So you have to, the return type will have to be your own custom type of multiple outputs. So that's what we're going to create now. We're outside of this thing here. Also, this means that we can probably keep this out of here, because the client call finishes and then we have all the data. So we can do that there. Probably right here. So we'll do public class my output type. And then we're going to specify the attributes that we want to utilize. So we'll say Cosmos DB. I think it's, I don't know why it's not autofilling for us. Cosmos DB output. And then there's a couple of things that we need to fill for. Will it tell me that it needs to? Okay. I know we need to provide the database name, which we added into the local.settings.json database name. I just want to make sure that they match. So we have database name, collection name, and then this string here. So database name. And then we need the collection name. And then we also need the connection string, which is going to equal, what did we call it here?
Cosmos DB. Yep.
Yeah.
It's better to copy paste.
Yeah. Honestly, I should have done that with the other ones, but all right. And then we'll just say okay, what object is going to be the output of this. And then we'll just say public coin. We'll call this coins. Then since it's a property, we'll have to have getters and setters. All right, so now we're getting an error. Probably because we're missing Cosmos DB output. It's not telling me which package to. Oh, here we go. Sorry. Generate. Oh, did we not? We have to add the package? Maybe we do have to add the package. I thought it came ready, but I guess not. All right, let me say .NET 5 Azure Functions. Unless I didn't have the website open yet, like the NuGet link. But we'll go to this page. Unless I do have the NuGet link. Let's see. NuGet. Yes. We'll look for Cosmos. Do you see Cosmos here? Cosmos. Here we go. And then we'll grab the CLI version.
Cool.
This is really slow for some. I don't know if it's my internet or. There we go. Okay. And then just make sure we're in the function. Yes, we're in the right. Paste that in there. Okay, so now I've added that package. Might as well add the SignalR one in here too. Go back. SignalR. All right, we'll add this one too, and then we'll add this one in here. Fantastic. So now when I go and move these things here. All right, it's probably not, it's connection string setting. There we go. So that's what we were missing. Okay, so now when our output type is going to consist of Cosmos DB output for right now. So that means we have to switch this from being a just normal task to being my output type. And I think we should be able to keep the rest of this the same, but it's giving us an error because we're not returning the proper type that it's expecting us to return. So now we'll do return new my output type, and we'll go ahead and provide the Cosmos DB. So that would just be goes to coins is going to equal prices, right?
Yep.
And I think that's it for now. Let's see if we get any errors. I'm pretty sure I wrote the settings correctly, but we'll take a look. If I didn't see, I knew I got something wrong. What? Exceptional execution for part does not. Format of initialization string does not conform to specification starting at index 0. Let's see, database collection name, connection string, Cosmos DB connection string. Wait, format. Get system data common format string does not conform to starting at index 0. I've never seen this before. Let's see if I got these correct. Database name, crypto coins, collection name, price, collection name, Azure Cosmos DB connection string. I copied this one, right?
Yep.
Cosmos DB connection string. That's there. Collection name is there. Database name is there as well. Wait, did I? Database name, price. You know what? This string, that doesn't look correct. Hold on. That looks a little off. Maybe I copied the wrong thing. Cosmos DB. Yeah, that's what's wrong. I think that's what's wrong. If I go back into here, so see, this is just like a bunch of letters. It doesn't have like actual, it's not like specifying an endpoint. So I go here, close that. There we go. That looks much better. So now we'll close this, run this. Let's see. Any errors? Doesn't look like it. Let's go. Let's go, everybody. All right, now let's open the Data Explorer and let's see if it actually pushed it to our collection. We'll go into price, items, and here we are.
Awesome.
See, it's these small things, these small details like that always get me. But yeah, so now we see that every time that we make an API call, it's just going to insert. So because I set the ID to be the symbol, so instead of it adding new data, like so sort of keeping like history of prices, it's just going to override it, right? Because for this specific use case, I don't have really, I don't necessarily care of like data that's been
Like
used like before. Yeah. Like I don't care what the price was like yesterday. I just want like real time now. But if that was something that mattered to you, then you would have to like structure your partition keys and such to be something different, right?
Yep.
Because the symbol and the symbol never changes, the name never changes for a coin. Actually, I don't think so, right? No. Cryptocurrency coins, they never change symbols like just randomly, right?
No.
All right, that's good to know. Okay, so let's should we keep this running? Let's think. Now we have to create. No, we'll have to create one more function actually. Yep. So now we have so we're calling the API, we're grabbing the data, we're saving it to Cosmos, but now we also need to save it, sort of send it as a message to SignalR, which is why we have the Azure SignalR connection string here. So for that, since we've already created our output type, we can go ahead and add it to right here. I think it's like SignalR output, I believe, SignalR output, and then we have to provide some details in here. But we also might need to create a class for our SignalR message. Yes, I know that. So we'll do public class my SignalR message, and we'll say here public string target. So target is the method that you're going to invoke on your clients. So if I name this, we're going to name it updated. That means that this message is going to target the updated method on the client that's connected to the SignalR instance. And then this is a property, so we'll have getters and setters, and then we'll have a public, we'll just do object for now, but this will be our actual arguments, our payload, which is an array of objects. We'll just call it arguments, and we'll just get and set here as well. Fantastic. So for the actual, the output, SignalR output, we need to provide our hub name, because you can have different hubs depending on like, what sort of messages you want to send to different I guess clients and connections and things like that. Yep. Which would be, we're going to call it hub name. We'll call it clients. I guess that's sort of appropriate. And then we'll have the connection string. Connection string, and then this needs to match this exact right here. I'm just going to copy paste this time to avoid errors. There we go. And then again, we just need to specify which one we'll be using. So public my SignalR message, which would be, we'll call it new message. No, I guess new message. That makes sense. Set and get. Yeah, my SignalR message, new message. Yeah, that's fine. So now in our return type here, we also need to have a type SignalR. So we need to create one first. So we'll do my SignalR message. We'll call it my SignalR message, I guess. And then we'll say new, my SignalR message, and then we'll open this up here because we need to provide a couple of things to it. We need to say the target, which again is the method that we're going to invoke on the clients that are connected. We'll call this updated, so this new data. And then we also need to provide the arguments, which in this case is what we're going to send, which is an array of objects. And then we're going to say that that is the prices array. Remember this thing?
Yep.
So the same thing that's going to Cosmos DB is going as a message to the SignalR instance here. And I think that's it. Do we need to, we might actually need to create a new, because this is of type object, right? So we're probably going to get an error there. So we'll probably need to do something like new object array. And in the payload, I guess, would be prices, like that. Yeah, something like that. So that way now in our return type, we'll do a new message is going to equal my SignalR message, right? So now when we run it, we'll have saved both to Cosmos DB and to SignalR. So let's see if this actually gives us an error.
Given that the connection string is right this time.
Yeah. It's always those small things. As long as we don't get an error, we're fine. It's sort of hard to visualize this actually working until you have a connected client that will receive the data. Yeah. But we didn't get an error, so we should be fine here. So that's pretty much our function that does all like manipulating data and things like that. Now we need to create an Azure function that will negotiate the connections from clients to the actual hub. And we create one called negotiate, which I think I've already created for us. No, I haven't. All right, let's go ahead and do that. So the Azure Functions extension, the Azure extension with Visual Code is actually quite handy. It'll like scaffold a lot of things for you. So I'm going to go ahead and hit this little add function thing. It's for negotiate, it's HTTP trigger. We're going to call it negotiate. Did I spell that right? Wait, this already exists. Hold on. Is it in here?
It should. I think it's already completed. Maybe.
Oh, so I added it to the wrong one then. So, maybe we'll have to do it. Create new project. I think it's defaulting to the wrong one. No, to the wrong one, right? That's probably it. Let's see. Local project functions. How do I make sure it's in the? Hold on. Let's stop this here. It creates in the new one. So we'll have to create one in the starter folder.
Yep.
Okay. Hold on here. Change. Yeah, HTTP trigger negotiate. Yeah, it's autofilling to the wrong one. We'll do. Odd. I don't think I've ever had this
error before.
Yeah.
Yeah, I guess we could open the starter folder in VS Code. That would solve it.
Yes. That way it stops getting confused. Okay, so let's close this out here. And then we'll do cd starter cd. I guess you think we could open here? That's fine, or should we do?
I think it should be fine. We'll see.
Yeah, and then we'll say our starter would be our API, right? Yeah. Initialize for optimal use of the VS Code. Sure. Don't ask again. Okay. So now in here we need to create our negotiate. We'll go into Azure, and then let's see if this works now. Here it should be negotiate. Nice. Thanks, Rishab. What would I do without you? Anonymous. Oh, this is fine. Okay, great. So now we're going to create that negotiate in here. This one is actually pretty straightforward as well, because you really don't have to change anything except you have to describe, not even describe anything really. You just have to like change this because it's not text. We're expecting JSON.
Yep.
So we'll do application/JSON, and then just for instead of giving like this generic welcome to Azure Functions, we'll switch this to do that there, and we'll say. Oh, you know what? We need to add the connection info as well. So that's there too.
First function basically gets the information from CoinGecko and then populates it to Cosmos DB, but also the SignalR hub. Okay.
So here in our negotiate, in order for it to know which like hub we're talking to. So remember in that first function that we just worked on, that's going to a coins hub. We also need to make sure that this one is negotiating connections for the same hub, right? So we'll put coins here, and then we'll just say that the string connection info will have our connection info. So when a client wants to access the SignalR, it'll get this connection info here.
So our front end would be talking to this function then.
Yeah, so in order for our front end to access the SignalR messages, it has to sort of find its way through this negotiate function. And we'll see what data it gives us. I think we can just do connection info here once we run it. Okay, I think that's probably string connection info, return, response. I think that's it. I think that's all we need. Now we should be able to debug this way because it's set to the only folder open is this one. Okay, so the thing about when you run multiple functions, so you see we have our trigger, so get coin prices, but we also have our negotiate here. We can actually click on this. I'm gonna just copy it. And then we'll open it up in our browser here, and then we'll open this up here and see what we get here is we have a URL and we have an access token. And this is what clients will use to connect to our SignalR service, right? So this function, we had to just add the SignalR attributes, and we sort of just printed the console kind of thing. I guess printed browser, not console. But that's really all we need in the middle for something in the front end to receive SignalR messages, right? Okay, so now we're going to keep this running because we need our API running in the back. But we could probably, I guess we can keep that running. And then we'll just open up our front end. Our front end's here as well, right?
Yeah. Indeed.
Or did we? Yeah, it's right here. So we'll start a new terminal, or should we open another VS Code instance? What do you think? We'll do, I will do another terminal then. And then we'll just have those we do side by side. I will just switch back and forth that way, not to get too confused, just because real estate is a little odd here. Okay, so right now what we have to change is instead of fetching data from
the API.
Yeah, we'll go here. Instead of fetching data from here, we'll have to fetch data from somewhere else, right? So hold on, let me open up the proper. One second. Where is it? Here? Nope. Here. Here. Okay. So we have to add some. Maybe not pack. Well, I see we have this already in here, so I don't know if we need to add it again. It's not giving us an error, but then again, our IntelliSense is set to the function. So we'll see what errors we get when we run it. So again, we have an array here of coins, prices, and again, it's using that the same set class. If we structured this a little bit better, if we used something like what is it? Azure Static Web Apps, we could be sharing models and things like that. So we wouldn't necessarily have to have the coin class here and then also in the API folder because we have two, right?
Yeah.
Right. But this is sort of a less efficient way of doing it. But there are other ways to sort of share models between back and forth, especially when it comes to Blazor. But yeah, we have this coin class. Hold on. Did I close the wrong one? Yeah, I closed the wrong one. We'll close this one here and we'll go back here. Yeah. So we have, again, our array here, and then we used HTTP client, remember, in functions to sort of make the API call. And then we're using that again here. But now we need to add a few more things before we sort of fetch what happened there. Okay. So the first thing is we need a protected hub connection, and we'll call this hub connection. And this is what's going to talk to the negotiate function and sort of connect to the correct hub. And next we need to know if the hub is connected actually. So we'll do is connected, and then we'll say, well, if the hub connection dot states equals connection state, this is probably dot connected. All right, so this is, I think this is it. Oh no, but this would be like that. Yeah, so right, this is just gonna be a true or false if it's connected or not, right? If the hub connection state is our hub connection is the same as hub connection state dot connected, which keep in mind this is lowercase, this is uppercase, so they're different, right? So as long as it's connected, then that will reflect on the value of this Boolean here is connected, right? So we can actually comment this out. We won't have any data initially until the SignalR instance receives more messages. So we'll add some space here. Because in here, we're going to have to start the hub connection. So we'll do hub connection equals new hub connection, and then we're going to tell where to connect it to, hub connection builder, and then we have to start it with URL, and then here's where we provide the URL of our negotiate function, which would be, since it's running locally, it's going to be HTTP local host, and then it's running on port 7071, and then it's API here, right? So this just matches like where our function was running, which is locally, and then remember we had in the functions in our local.settings.json we had our local port for course, so we have that in there too. And then we have to say build. I think it's not, the IntelliSense isn't working here. Because it should tell like autofill for me, unless we're missing like some sort of package or something like that. Okay, so we're building a new connection with the hub connection builder to the negotiate function, right? And then we actually have to turn it on. So then we say hub connection on, and then we know we're expecting data of type coin. That's not it. Data of type coin, and this is the part where we add in the target that we were mentioning. So remember, we told the SignalR output to sort of trigger the updated method.
Yep.
So that's what we need to provide this same name here. If we made it different, then it wouldn't be listening to the right one. And we'll just say we're going to be working with coin. Then we need some space here, and then we'll probably need to end this here. And then in here, we need to provide so prices is going to equal coin. Remember, prices is the array that we're working with here. So in order for our front end to sort of work and manipulate with objects, we need to save it somewhere. So we're going to say, all right, so that coin that you're receiving as the argument, remember we have target update, and then the argument that we're sending. I'll show you that in a second. So we're going to assign this argument, which is again an array of objects. That's coin is going to be set to prices. And then we'll just close that up there. And then since this is Blazor, and in order to render data in components, we'll have to tell it that the state has changed. State has changed. And close that up there. And then there, I think that's good here, right? And then we actually connect. Connection dot start a sync. All right, cool. I think that is, we'll probably have to dispose, but this might work without doing it for right now. So we're to make sure we're in the front end. Yes, we're in the front end. Let's go crypto ticker. And that is our front end, ls.net watch run. Let's see what errors we get. Let's open it on our browser here. Oh my goodness, that's way too big. All right, so again, this is a very familiar, it looks just the same, right? But here we have loading, because we don't have any data coming in yet. If we go into, trying to do like a side-by-side, no, I did this wrong. Here we go. Let's go like that. Move this out. No, I keep doing this wrong. Well, the goal is to get every time the function is outputting. How do I close these? Do I just go unsplit? All right. Well, the thing was in the background, you saw that data load, right? Okay, unsplit, and then no, unsplit terminal. There we go. So let's see if I can do this this way. This one is not needed, and that's our front end, and then that's our. It's so hard to not click that split because it tricks me into doing it. All right, so there we go. So the next time our function runs, the data will load again. I'm trying to get it so we can see when it's actually like loading, like when it like prints the console again.
Yeah.
Hold on.
I think we will have to wait.
Let's refresh. All right. Oh. So the last time I executed was at right there. And then there we go.
Yep.
All right, that worked. That's the best you're gonna get right now because it's hard to sort of have the things open with the prices the font so large. Okay, so what's going on is every time our function is publishing data to Cosmos DB and SignalR, our front end is reloading the data. So with the limitation with functions is that it's only, I think the quickest you can get it to like repeat is 60 seconds. I actually haven't looked into how you can like sort of work around that. You might be able to do it quicker. Yeah, I didn't look into it. I don't know if you know. Do you know if we can do more than 60 seconds or like 1 minute? Because your cron tab, like for example, in your timer here.
Yeah, we can reduce that, but then yeah.
So here it's set to, where's our, oh, that's to negotiate. Coin API, no. Here, this one.
Yep. This
is like you can't do it like 30 seconds or 15 seconds, right?
I'm not sure. Like,
all right, anyway, here, so now where we're at, let me pull up the GitHub repo here. So now we're at here. We took our starter project and then we created that negotiate function. We'll start right here. We created our function that runs at every 60 seconds and makes a call to the CoinGecko API and then saves all that JSON to our Cosmos DB. Well, that function will also, since it has multiple outputs, remember we created a custom multiple output, my output type, and that's saving to SignalR, which the hub is called coins, and then also to Cosmos DB. Then we have the negotiate function, which will allow clients to connect to the SignalR instance, and it provides that URL and that token and such. Which was this negotiate one right here, right? This is the one that when we clicked on it, we saw a bunch of like the URL and the token and things like that, right? Then we had our Blazor WebAssembly that instead of us having to reload it constantly every minute when there's new data coming in, it'll load on its own, right? We saw that sort of tricky to demonstrate it because of the size of the terminal and such, but we've finished it. I think that's it. Oh, I guess so. I guess the one thing that you could probably do is, so initially when it's still loading, if we go into here, if we have the fetch data, this is why I like commented out this. Like you can have it load from somewhere else, and then that way you're not waiting the first time if you wanted to.
Oh, okay.
So if I like remove to this, and I go here, and I'll close, like run this again.
So it won't have that loading bar in the beginning.
Yeah, the first call will be to like API. Some API.
Yep.
See, that's some API, and then the data will update each time there's a SignalR call, right? So we'll wait again. We'll wait a quick second, or max 60 seconds until new data reloads in. What does the chat say? I haven't been paying much attention to it. I've been so focused in fixing all these issues that we've had in our code.
Yeah, I think the only question or suggestion that was with the Cosmos DB connection string that we got wrong. But other than that, yeah, there haven't been a lot of concerns. Just people are joining in late.
The CoinGecko is I thought it was a gecko.
I thought it was a toad, but yeah, it looks like a gecko.
We can switch to full screen. Timer trigger 15 seconds, should be 15 seconds. Hold on, let's switch to, we'll switch to full screen and like sort of do a little Q&A because we have a little bit of time. All right.
Yep.
I think we got cut off on Twitch from what I'm seeing. Did we get cut off on Twitch?
For me, it was works.
Was it fine?
We got a warning that said that it disconnected for a second. So I don't know if it really impacted them that much,
Okay.
They put an ad in.
Seems like we're back online though.
They put an ad in? Oh my goodness, can you imagine?
I saw an ad.
Free publicity. Yeah, I just wanted to say I saw a bunch of like highs in there, so that's nice. It's always nice for people checking in. Let me take a look here. Oh, someone says love my videos. Thank you.
They also said they purchased a product because of your review.
Really? Your HP Omen review video made me buy. Oh goodness. I need to cut HP. Where's my percentage? But yeah, that's cool. Everyone knows I'm a pretty big fan of Azure Functions, serverless. You know, Cosmos DB was also running in the serverless mode, so it becomes extremely affordable. Especially if you're doing like side projects, things like this, that unless you're like trying to build the next, I don't know, TikTok or Instagram or something like that. And then you probably need to look into something for more of a traditional load. But again, I'm a massive fan of serverless and how it enables you to sort of build these end-to-end solutions that you can completely own as a singular person, like a one-person team and such. And it's great for building small things, add-ons to already existing solutions, or you can, create like full-on things with full serverless. Rishab, I think you're sort of starting to dabble in Azure Functions and things like that.
Yeah, I think I explored it a bit last year with the resume API endpoint, but after that I haven't done any projects. But yeah, this gives me a good chance with the 30 days challenge.
Oh, absolutely. Someone did mention that it looks like cloud roles require a lot of coding skills. So I would say it depends on if it's the September series is focused around cloud development and then developer tools and services and things like that. So for that specific slice of the cloud computing, I guess, field, yes. But there are other fields in cloud, you've administration, you have DevOps, you have security, architecture, things like that you won't be utilizing full-on programming like we're doing in here. So if coding is not something that you want to get into, there are definitely other spaces. And I think cloud, it's so large that you can find something that you can a fit that'll work better for you. I know Rishab, your experiences now is with DevOps, and the majority of programming you do is Python, YAML, but more in the sense of automation versus actually building full-on solutions, right?
For sure.
If you are interested in more developer things, I'm doing these developer-focused streams for every Wednesday of this month. And then Rishab is going to join me in the last Wednesday where we're going to take this app and we're going to containerize it. And I know nothing about containers, so I'm going to learn a lot on that one. I hope you all continue to watch these streams, and I'm going to try to keep them as informative and casual and as concise as I can, because I don't like to waste anybody's time, right? With that being said, I think we can wrap up. I think we're right about at the 1 o'clock. Take a look at the GitHub repo, and you have all the code that we worked on today.
Awesome. Thank you, guys. So yeah, I'm going to do a little plug here just to wrap it up. So let me pull that up onto the screen. 1 second. Hang on 1 sec. Oops, wrong one. Let's change that back. Here we go. There we go. Sorry about that. I'm still reasonably new to StreamYard, so finding all the different views is, fun. So as Gwyn mentioned, next week, next Wednesday, same time, same place, we'll be having her next session, orchestrating long-running workflows with durable functions. So definitely come check that out. We will be streaming it on Microsoft Reactor YouTube, Gwyn's YouTube, which is the GPS, on ideally Twitch without issue, LinkedIn. So definitely come by, check it out again. And these sessions are recorded, will be live on both her YouTube channel and the Microsoft Reactor YouTube channel. So definitely check those out if you miss them. Also, if you were trying to follow along, maybe at some points it went a little bit fast, you can certainly go back and review. And then again, this is part of the 30 Days to Learn It challenge. She's covering some topics that are from that Learn module. So I dropped those links into the chat. So definitely click on those, follow through, see if you want to sign up, interested in learning more and participating in the challenge. Otherwise, you can just join us on these sessions, and they're kind of standalone as well. I'm going to drop into the chat our survey link. Please let us know how you feel and if you like it. If you like this session, if you have suggestions for future sessions, definitely give us some feedback on that survey. And enter event code 14168. And then if you're joining us for the first time, please think about joining our community. The Microsoft Reactor is free community content. We put out a bunch of streams and eventually in-person sessions. Internationally, we have 11 physical spaces, and you can follow us on Meetup. You can go to our main website, microsoftreactor.com. Events happening within your region. So yeah, I've seen a couple of comments come through while I was going on. Do you have the GitHub link handy, or I can drop it in?
We just shared it in the chat.
Oh, you did?
Yeah. So it's
cool.
Yeah, and someone said, if would I do more administration cloud roles, like streams around that? That's a good recommendation. I would say make sure to sign up for our newsletter and keep up to date. I'll keep that in mind. I'll try my best to fit it in somehow, somewhere.
Okay. Awesome. Well, thank you all so much. Thank you, Gwyn. Thank you, Rishab. This was fantastic. And thank you to our audience out there participating and following along. And until the next one.
Bye, everyone. Thank you.
Bye-bye. Take care.